Human hair is a complex structure divided into 3 distinct layers: the cuticle, cortex, and medulla. The cuticle is the outermost layer of the hair, and its function is to protect the cortex from damage and moisture loss. Formed of colorless, translucent scales, it is hydrophilic or water-loving and has the ability to expand and contract as it takes on or releases water. On fine-textured hair, there may only be 4 layers of cuticle. On coarse hair, there may be as many as 18 layers of tightly compacted cuticle. In order to create a permanent color change to the hair, the cuticle must be expanded to gain access to the cortex. Expanding the cuticle layer must be done carefully so it can be contracted and smoothed down again, leaving the hair shiny and soft. The cortex is actually the strongest and most vital part of healthy hair and represents approximately 85% of the hair's total weight. It consists of numerous twisting fibers of keratin protein which run parallel to one another. This cortex is where the melanin, or natural color pigment, resides. The medulla is the innermost portion of the hair shaft. It is composed of mostly soft keratin protein and air spaces, having no specific function, size, or shape. Often fine hair will not even have a medulla, whereas coarse hair textures will have a large medulla. The chemical makeup of hair. Human hair consists of proteins and moisture content. The remainder is made up of carbohydrates, lipids, mineral elements, and pigment. Carbohydrates provide flexibility to the hair, lipids help create shine, and minerals add strength. Atoms are the building blocks of amino acids. Proteins are comprised of amino acids, which are compound molecules that link together to create polypeptides. They are commonly referred to as the building blocks of protein. There are 21 amino acids in the human body and 18 that relate to hair. Amino acids make up all of the protein in hair. All amino acids have an acid head and an amine tail. The amine tail is alkaline and is represented by a negative sign, while the acid head is acidic and is represented by a positive sign. When an acid head of one amino acid joins with an amine tail of another, it creates a peptide bond, also known as an N-bond. The 2 amino acids connected by this N-bond create a peptide. Peptides link together to create a polypeptide. Multiple polypeptides create a polypeptide chain. When a polypeptide chain has enough amino acids in it to equal multiple proteins, it is considered a protein chain or helix coil. Polypeptide chains are cross-linked by covalent or side bonds. They twist around each other to form a helical coil. Approximately 7 to 9 of these helical coils twist and bind to form larger bundles called microfibrils, then twist again to form macrofibrils, and then twist once more to form fibrils or cortical cells. The side bonds. Hydrogen bond. Hydrogen bonds make up 1/3 of the hair's total strength. Although hydrogen bonds are the weakest of the side bonds, they make up the largest amount of the side bonds in the hair. Hydrogen bonds are ionic, easily affected by water and heat. Salt bond. Salt bonds account for 1/3 of the hair's overall strength. Salt bonds are ionic, fairly weak, and are greatly affected by changes in pH, such as shampoos, conditioners, and hair color. Disulfide bond. These bonds are the fewest in number and the strongest in the hair, and are responsible for 1/3 of the structural strength. Disulfide bonds are affected by reactive chemicals such as relaxers and permanent waves. Melanin. The enzyme tyrosinase and the amino acid tyrosine, carried in the bloodstream, combine in the hair bulb to create melanocytes. Melanocytes are specialized cells that create all of the melanin found in the hair, skin, and eyes. As melanin is formed, it travels up the hair shaft, becomes keratinized, and then physically becomes part of the cortex. The color is then reflected through the translucent cuticle layer. When hair begins to lose color or becomes gray, it's because the body no longer produces the necessary quantities of amino acids to promote the production of melanin. When production stops completely, the hair becomes white. Melanin makes up approximately 1% of the total structure of hair and is found in the cortex. There are two types of melanin most often discussed. Eumelanin, found predominantly in black, brown, and brunette hair, levels 1 through 5, and is black to brown in color. Eumelanin contains more iron and when oxidized turns red. Pheomelanin, found predominantly in red or blonde hair, levels 6 and lighter, and is reddish-orange in color. Pheomelanin contains copper and turns orange when oxidized. Basic chemistry. In order to understand pH, it is necessary to understand ions. An ion is a molecule with an electrical charge. When a molecule ionizes, it splits into two parts, creating a pair of ions with opposite electrical charges. The ion with a positive charge is called a hydrogen ion, which is acidic. The ion with a negative charge is a hydroxide ion, which is alkaline. pH is only possible because of the ionization of water. Therefore, pH is only present where there is water. pH stands for protens hydrogen, which means the strength of hydrogen. It is a range of numbers expressing the relative acidity or alkalinity of a solution. The pH scale is a measurement of acidic and alkaline ions. When the amount of positive and negative ions is equal, the pH is neutral or 7 on the pH scale. When more positive ions are present, the pH is acidic and will register below 7 on the pH scale. The opposite applies when there are more negative ions present. The pH is alkaline and will register above 7 on the pH scale. The pH scale ranges from 0 to 14 and is logarithmic, which means that moving either way on the pH scale results in a 10-fold increase in the degree of alkalinity or acidity. For example, if you start with a pH of 4 and raise it to 5, the pH is 10 times more alkaline than before. If you raise the pH from 4 to 6, it is 100 times more alkaline than before, and so on. Let's take a look at where things fall on the pH scale. Acidic, hydrogen peroxide, 3.5 to 4. Healthy hair, 4.5 to 5.5. Color Protect Daily Shampoo, 5.5. Neutral, PM Shines, 7. Pure Water, 7. Alkaline, Permanent Hair Color, 9.2 to 10.5. Lightness, 10. Ammonia, 12. Classifications of hair color. Semi-permanent. The dye molecules sit on the outside of the hair. They do not penetrate into the cuticle and last 2 to 3 weeks. Demi-permanent. The dye molecules will penetrate the cuticle without lifting and last 6 to 8 weeks. Permanent. Oxidative dyes that produce lift and displace melanin. Permanent hair colors are generally marketed as two separate components. One component contains the dye precursors and ammonia in an alkaline base, and the other component is a stabilized solution of hydrogen peroxide. The two are mixed immediately before application. When the mixture is applied, it diffuses into the hair and rapidly reacts or oxidizes and forms the dye or color. Oxidative dyes normally have an alkaline base and include either ammonia or an ammonia replacement in the formula. An alkaline environment is required to swell the hair, open the cuticle layer, and allows oxidation to begin. Ammonia. Ammonia is an inorganic alkali used in permanent hair color. It evaporates quickly. Ammonia is alkaline and raises the pH of hair by removing positive ions, which leaves the hair in an alkaline state. Two negative ions will repel each other, just like two negative sides of a magnet. This makes the hair swell and separates the cortical cells, causing what we know as porosity. Hydrogen peroxide. One vital and often misunderstood ingredient used in creating artificial hair color is hydrogen peroxide, which is a combination of water and oxygen. When mixed with ammonia, it generates oxidation. The volume of hydrogen peroxide varies and is chosen for its ability to control lift and coverage. It is important to understand the difference between volume of hydrogen peroxide and percent. The words are mistakenly used interchangeably. The strength of hydrogen peroxide may be expressed as a percentage strength or as a volume strength. Percentage strength is the number of grams of hydrogen peroxide in 100 grams of solution. so that a 3% solution contains 3 grams of hydrogen peroxide and 97 grams of water in 100 grams of solution. Volume strength is the number of parts of oxygen measured by volume. A 10-volume solution of hydrogen peroxide will give off 10 parts of oxygen from 1 part of hydrogen. Most commonly used are 5-volume, 1.5%, 10-volume, 3%, 20-volume, 6%, 30-volume, 9%, 40-volume, 12%. Chemistry of lightning. During the coloring process, a certain amount of lift is achieved using higher volumes of developer and/or higher levels of hair color. The amount of lift available with color is limited, and for many techniques and target levels, the use of lightener is necessary. The most effective lightener is hydrogen peroxide. However, this works slowly and expires quickly. Therefore, other products are necessary to generate sufficient lift within a reasonable amount of time. There are many different types of hair lighteners available, but they always employ in their mixture hydrogen peroxide as the active part of the lightening process. Lightening agents are made of 2 basic parts: an oxidizing agent, usually hydrogen peroxide, to provide the oxygen for lightening, and an alkaline substance to act as a catalyst in breaking down the hydrogen peroxide to release the oxygen. This part of the lightener preparation is often a thickened consistency, forming a paste, creamy mix, or a gelled oil mixture. This preparation is then mixed with hydrogen peroxide immediately before use. During the lightening process, the eumelanin and the pheomelanin in the cortex are oxidized to colorless compounds. The goal of lightening hair with lightener is to oxidize the melanin with as little oxidation of the bonds as possible to minimize the damage to the hair.